Hello, good day. Thanks for joining me for this video. So this video will be continuation of my last video on beams and when it's acting as a point load. So the general feedback I got was that I should not make the video to be too long. So that's why I tried to make it as short as possible. Otherwise, we would have discussed what we are about to discuss today in my previous video concerning beams when it is arranged to form point load. So this video will be a continuation to that, and it will be very short. Now, from what I discussed that the software does not see beams as point load. Now let's now look at the recommendation of the developer of the software, because it will seem as if the developer did not consider that. No, they actually consider that, but this is their recommendation for different areas of design assumptions. The developers have made there's what they call white papers based on different topics, and you can download it from their site. If you check now, you can see this is Proto Structure Design Guide, 3D effects of continuous primary and secondary beam analysis. And they also have for 3D effects, effects. So they have so many white papers, and you can download from the site. Now, this particular one for beam is that they make recommendations and they explain how the software takes care of the beam acting when you consider beam as secondary and primary, which is acting as point load. Now, if you read carefully the white paper, in my previous video, I made I showed you what I observed, that it doesn't read point load, and I showed you how you can define the point load if you want to. But now for the developers of the software, the recommendation they made is that we do not have to define additional point load, because they you can see here in this paragraph they are making reference to how we do our 2D analysis when we pick the beam part by part and we make our analysis. Now in the program, you can see in the 3D analysis program such as Proto Structure, the analysis method is different. So they are saying that the entire 3D model is analyzed and solved simultaneously as an indeterminate structure. So primary and secondary beams will act together in unison to support the slab loading simultaneously. The proportion of loading sustained by primary and secondary beams would depend on its size and relative layout. Deflections of primary beam affect secondary beams, vice versa, as they are connected together. That is, there is compatibility in deflection. And this is they made example. I have also made something similar. It's not the same dimension, but I've made something similar. Now, my concern is this. Yes, the software analyzes as in unison as a 3D effect. So that means we analyze as 3D, but we construct in parts. So the question now rises as the structural engineer is that what is my assumption, during design stage, and what is my construction technique? I think this plays a major role in how we model and how we analyze structures that we eventually have to, execute in real life. Now I have done the analysis here. Let's see the analytical result. So the general recommendation by the designers, by the developer, sorry, is that you size your beams appropriately, and there's no need for us to define additional point load. You can see in the summary and conclusion, the continuous beam analysis using Protac structure 3D stiffness analysis is different from traditional 2D analysis. The key difference is in 3D analysis, the connected beams, both primary and secondary, are analyzed and solved simultaneously as indeterminate structure. Bigger and hence stiffer beam will naturally behave like primary beams, vice versa. This is no way. Now they are saying there is no way and no need to force a particular beam to be primary or secondary. The user should just size beams appropriately. Now note this word, size beam appropriately. All connected beams must have the same deflection at the common joint. Traditional assumption where there must be hugging moment at the primary beam support is no longer valid. The 3D stiffness analysis result is not unique to Protac structure. Any 3D general analysis program will give similar result given the same model. You can export Protac structure model to SAP or ETABS for further verifications if desired. Now, the resultant 3D movement is best viewed by assessing the 3D analytical model and reviewing the 3D deflections, as the deflections are direct reflection of forces and beam. That is the recommendation of the developers of this software, and you can see the movement here. Now note where I stress that they said you should size your beams appropriately based on how you idealize, how you want to predict that your structure will behave. Now the question that now arises from this assumption is that what is my construction technique? If I analyze as a 3D effect and I'm going to construct impacts, then what is the effect on that? Also, we have to note that there are settings that are involved in the program that affects your design output. Now, you can see this case that rigid zone, they say, is reduced by 25%. If you pick this option, you will have lesser movement than when you pick this option that you are assuming that non-rigid zone. This rigid zone story degree of freedom will be another topic in my subsequent videos that we will discuss. So again, also this beam analysis and second model, whether you pick rectangular or flange, all these settings have effect on the eventual movement that you will get. So the question arises as a designer is that which case will give me the best for my assumption, for my idealization that will work for me. Now this is something that you can't find anywhere if you check, except probably maybe if we have opportunity to be trained by the developer and they give us the best option that will best give us something that will say, okay, we are confident in. So but as the case is for different individual, if you don't know all these things, you can just go online and see a video on YouTube and they will tell you, okay, pick this option, pick that option, and that will work for you, and you go ahead without having full understanding of how the software operates and what your best options are. Like I've said, I have tried different scenarios. Now with the options I pick, you can see that this moment is this at this time. Now let's see if I pick another option and see what the result will give me. You note 333 there. Now let's say I have this model option. I say flange, and now I have picked ridges zone to be none. Now let me perform the analysis again, and let's see. So in essence, the major thing as an engineer is that when you model and you predict that this is how your structure should behave, then it calls for concern when you are employing the any analytical and design software. It calls for concern for you to know how the software operates, so that you can best come up with output that will reflect your design intention. Now you can see now that in this case I have more higher moment, 383, 333. So the question for me is, which option will now give me the best case scenario for my structure that I want to design, so that I won't under design and I won't over design. So it is not left for you. This is the recommendation of the developer of the software. They are saying that we don't need to define additional point load. Then how do I employ the software with the right settings to model exactly as I want my structure to be? Now have it in mind that you as the designer, when you employ the software to design, you also have to factor in that what is the method of construction. Is it going to be frame, or we'll use our normal traditional method whereby you put on the block work, then you do the columns and all that. So it calls for concern. Now we can have less worries if we are dealing with one suspended slab and all that. But when you have more than two suspended slabs, then all these things cause for concern, and it is very very important. So for me, I always want to relate whatever I use any 3D analysis software with. What if I'm doing it the other way, the 2D analytical method, the traditional method of doing it, so that I can have basis for deciding what and what to adopt and what and what to do. So it also calls for understanding the software and how it operates before you can employ it for any major project that you want to embark on. Like I said, this is the concluding part to the previous video I have done. So whichever stand you take as a designer as regarding to employing the software, it is left for you whether you want to define the point load, or you want to go ahead and leave it as it is. But you have to bear in mind that if you are saying a 3D, then you are saying the structure is one and is behaving as one. But when we construct in part, and also the behavior of your structure will also have to be considered in relation to how you execute when you get to site. So this is very very important, and you can make your own research and figure out where you want to stay, whether to define it or whether to leave it as it is. So it's the choice is yours as an engineer. So in summary, the recommendation of the developer of the software is that you size your beam appropriately based on your arrangement. Now, what I want to show you last before I end this video is that you have to understand that all these beam arrangement that are acting as point load on this beam, you have to define them properly. What do I mean by that? If I click on this and delete, let me delete this and delete this slab and delete this slab. Now if you go ahead and put beam, I say I want beam to be here from here. Now in some cases you have this beam and the software will read it as cantilever. It's not showing what I want it to show. Let me delete more so that I can show you some things. So I have beams, let's say 50 by 500. Now if I draw this beam, okay, now it's showing the line I want to show. Now you can see that it's showing this red arrow line. So what that means is that it's seeing it as a cantilever. So if I have another beam that goes from here to here, and I have another beam that goes from here to here, so you can see that it's seeing these beams as cantilever. So anytime you have those cases, what you need to do is that you click on this beam and you now define it and tell the software that it has support at both ends, so that that mark can go away. It has support at both ends, so that you can accurately the software can accurately see this beam the way it is, and the assumption of 3D analysis can take effect. So that's another thing you have to watch out for when you make your model. You have to make sure that all these beams that are connected, that doesn't have column, then you have to define them as being supported at both ends, because that's how the software will read it properly, so that you can have a result that will best reflect your intention as an engineer. So I hope this video helps you make decision and revise how you work and how you use the software. So before I go, I will, like I've said in my previous video, the software is to automate the process, then it is your own duty as the engineer to do the engineering. So thanks for watching this video. I'll see you in the next video.